So hello everyone, we are going to discuss about Markov process. Markov process is a process which is a stochastic finance process which says that today determines tomorrow and the past values from distant past has got no connection with the predicted value tomorrow. Moreover, Markov process comes with martingale concept. Therefore, it comes with probabilistic measures and not predictive analytics measures. These are mathematical models. These are not analytics or machine learning models. Therefore, more than prediction, they predict a range based on probability. Markov model is the base along with martingale, along with IID, independent and identical distribution. These are the base, these are the foundation of most of the stochastic models such as Black-Scholes, such as Heston, such as Cox, Ingersoll Ross, such as Vasicek, etc. Another important thing in Markov model is linked close to game theory and Markov model is linked close to Russian roulette. In fact, it originated from Russian roulette. So keep watching this space for the derivation of Markov model. Today, in the next video of the stochastic finance concepts, we will derive the most important stochastic finance concept, which is called Markov process. Markov process as a theory says that today is ultimate, which is determining tomorrow. Therefore, distant past has got no connection with tomorrow's prices of any stochastic series. And the first and the foremost stochastic series is stocks. So stock prices of today can determine stock prices of tomorrow. That is a concept of Markov. So another concept in Markov is that there are states. So let's take the states. So let's define the states. So let's define one state S, which is called bull. So if it is bull, we will represent by S. If it is bear, we will represent by R. And if it is range bound, we represent by C. So we just named three states here and we are going to construct a transition matrix of states. So what typically Markov model does, it does a transition matrix of states. It does a transition matrix of states. Now watch carefully, this is S, this is R, and this is C. So let's start from R. Now R has a probability of repeating itself. I will tell the meanings later. Kindly watch now, then I will tell the meanings in some time. R to S the probability of 0.4 and R to C the probability is 0.1. Therefore the total probability is 1. Now come to C. C repeating itself has a probability of 0.3. C to R has got a probability of 0.5, therefore 0.8, and C to S has got a probability of 0.2, therefore makes it 1. Now S has a repeating probability of 0.6 and S to C has a probability of 0.3, therefore we are remaining with only 0.1, that is S to R. So we all know total probability is always 1. Repetition of the same state has a probability. So S has a repetition probability of 0.6 means 60% time a bull market today will have a bull market tomorrow. R has a probability of 0.5 of self-repetition. It means 50% chance that if today is a bear market, tomorrow will also be a bear market. C has a self-repeating of 0.3 means 30% chance that if today is a range-bound market, tomorrow also is going to be a range-bound market. That's a concept. Now let's make the transition matrix first. So I'm just drawing a basic transition matrix here for you. So this is S, this is C, this is R, this is S, C, R. S and S, that is S repeating is 0.6, S to C is 0.3 and S to R is 0.1. Similarly, I repeat it for the others. You can cross check obviously. And now, after the transition matrix is done, let us ask the most valid question. Today is C, that is range bound. What will be the chances of R tomorrow? That means, what is the chance of a bear market tomorrow? So we have to take from this C to R. So you just follow the pen that I'm following here, C and R. Because C is the current state and we are targeting the R state. Therefore, we will take the row of C and column of R. So how the calculation looks like? Calculation looks like this. So we will first take the row of C. This is the row of C. 0.2, 0.3 and 0.5. We multiply it a matrix multiplication, simple matrix multiplication here. So this is R, 0.1, 0.5 and 0.5. Therefore, if I complete the matrix multiplication, it will be 0.2 into 0.1. That means this gets multiplied with this. So I can show with a different color pen here. So typically this gets multiplied with this gets multiplied with this, and this gets multiplied with this. Plus 0.3 into 0.5 plus 0.5 into 0.5. Therefore, the total probability is 4.2. So 42% probability that tomorrow will witness a bear market. So today is range bound, tomorrow can be a bear market. So another important thing we have to know and note here, that Markov models are memoryless. Memoryless means the coefficient of correlation of, suppose someday in the past, let's say 190y, that means 190 days before, and the coefficient of correl with y0 is today. This is basically negligible, say very, very small. So the assumption is that the market is memoryless, that there is no memory in the market. Market cannot remember the past. So memoryless random variables. So Markov takes assumption that memoryless random variables are there. So therefore, two thought processes are there in the market. One thought process says that market has a memory. Another thought process, which is Markov, says market do not have a memory. We are not debating which is correct, which is wrong, etc. Some people follow the first one, some people follow this one. So in this Markov process, we understand that today is going to determine tomorrow. Thank you very much. Stay tuned for more videos.